Hi everyone, my name is Albert Anwar, and today I'm going to be presenting my honors capstone project, which is MobRob, an inexpensive and modular robotic arm for hobbyists. The project's focus area is in entrepreneurship, and I'm advised by Professor Grace Xiao. First, a bit of background. Today's industrial robotic arm industry is application-centric, with each model designed for a specific application for a specific customer. This means that demand remains low for a single arm solution, but since the time and money needed to design such a solution is high, the price remains high too. For example, a single industrial robotic arm can cost anywhere from $25K to $400K. The robotics industry is now moving towards lower-cost solutions such as mass-produced robots and eliminating some of the costs of engineering an arm, such as software frameworks that make programming easier. With this background information in mind, there were three objectives of the project. The first was to perform customer discovery and to assess a desire for a modular, mass-producible robot arm. The second was to design a robot arm model that is general enough for mass production and higher volume sales. And last but not least was to provide a robot arm model that is easy to assemble and to configure for different tasks. To achieve these objectives, I started with customer discovery and market evaluation to assess the market demand and desire to purchase a robotic arm. The first step was to provide a survey to assess the current process of building and prototyping robotic arms. Then the data from the survey was processed to build customer profiles, and finally a literature review was performed to assess the overall market for robotic arms and the potential for inexpensive modular robotic arms. The customer survey assesses the current robotic arm prototyping and building process, including the time and money spent. It also asks about the willingness to spend on a product that would facilitate that process. You can see some example survey questions on the slide, and also a link if you want to take a look at the survey yourself. The survey data was summarized into quantitative and discrete results, and pivot tables were generated to find trends in the results. As of this point, 8 people have responded to the survey, and I was able to build 2 customer profiles. First is the high school student or teacher, and the second is the graduate/college robotics researcher. Some interesting results that I found include that those who work with robotic arms on the college/graduate level seem to be willing to spend more on an inexpensive robotic arm that would take less time to assemble and program. And the second is that many are willing to spend more than $500 on a robotic arm. I've also gotten responses that indicate that people would pay more than $1,000 on such a product. I've also done a literature review that looks at current robotic trends, future applications of robotic arms, and the feasibility of modular robots. I've looked at 26 works through the University of Michigan Library, and it seems like modular robots have potential applications in future robotics industries. From the results of the customer discovery, I designed a system architecture for an inexpensive modular robotic arm. The arm would consist of multiple robotic arm joints that would communicate wirelessly to a robotic arm base. These joints are meant to be exact copies of each other and to allow the user to easily add or remove joints as they wish and have the arm assembly work within minutes. Each joint consists of a servo motor with a position sensor, a battery to power the servo, and an ESP8266 running a piece of software called Robot Operating System, or ROS. These joints will communicate wirelessly through ROS to the robotic arm base, which consists of a Raspberry Pi Zero W, as well as a couple of buttons to provide user control of the system. Since each joint contains a lot of different parts that need to be packaged concisely, I designed a casing for the arm joint. The casing was designed in CAD using Fusion 360 and manufactured through 3D printing. After many hours of designing, manufacturing, assembling, and coding, I've produced a minimum viable prototype of the robotic arm. With this prototype, I'm able to push a button to record the position of the servo in each joint. After moving the arm to a different position, I can push another button to move the arm to the recorded position. Although fairly limited at this point, this functionality forms the basis of having a user record entire arm motions that can be replayed at a future date without ever touching a line of code. The cost of the prototype was quite low. Each arm joint cost around $43 and the controller cost around $18. This means that a 4-joint arm assembly can cost under $200. And if you compare that with what's on the market today, I've used a robotic arm in a classroom that costs $1,800, which is a massive cost reduction. In conclusion, modular robots are a feasible, inexpensive, and easy to set up solution for the future robotics industry. Many are willing to pay high prices for such a solution, and it has applications in the education and research field, as well as for hobbyists who want to create their own robotic arm. In the future, I'd like to gather more responses from the customer survey to validate the results I've already received, and also expand the prototype's capabilities and designing the arm so that it's more robust. And lastly, I want to thank my project advisor, Professor Grace Shaw, for mentoring me throughout the project and providing valuable insights and connections for the customer discovery portion and market evaluation. I also want to thank Rachel Armstrong-Sarin and Professor Jason McCormick for reviewing and supporting my project proposal. I'd now like to address a couple of questions you may have. Firstly, how did I connect with my Capstone advisor? I met my Capstone advisor, Grace, because she was teaching ENTR 411, which is a class I took last semester. I'm an entrepreneurship minor, and the class is a required entrepreneurship practicum class for the minor. I chose her because I knew that customer discovery and validation was something I was uncomfortable with and needed guidance on more than the actual engineering portion of the project. And she has been incredible in guiding me in that aspect. Secondly, how do I hope to use what I've learned in the project in my future career? This is one of the first times I've felt like I've had a very in-depth customer discovery experience. So I think going through the whole customer discovery and market evaluation process is something that I'll be more confident in the future. I also learned how to use ROS, which is something that I wanted to know since taking EECS 467 last semester. And I think it'd be really helpful to use on any robotics projects that I decide to do in the future. It would be very interesting to continue with that project, like gathering more responses to the survey and improving on the prototype after I graduate, since I think it has real potential to transform the current robotics industry. And last but not least, where is this project going from here? What are the next steps? This project is nowhere near complete, but I haven't decided whether I'll continue it after graduation. Whether I do that depends on quite a lot of factors, and it's probably a decision that I'll make once I move out to work full time. If I do continue or decide to continue, I will continue to perform customer discovery and improve on the prototype and consider turning the project into a proper startup. That's it for questions. Thank you all for watching.